guys, I'm gonna go ahead and solve the number 2 problem on the independent practice. Okay, so if you look at the three equations, you notice that this equation has all three variables, but look at the second equation. We have an x and we have a z. And then on the third equation, we only have a y and a z. The best bet is to eliminate a variable that is in all three equations. So I'm going to get rid of c, and let's go ahead and number the equations. Okay, once I do that, let's go ahead and pair 1 and 2 together. It doesn't really matter, but let's go ahead and pair 1. It's negative 3x minus 3y plus c equals 6. And then I'm going to go ahead and pair 2 together, and that's a 2x plus z equals negative 8. Now, in order for you to get rid of z, you need to multiply one of the equations by a negative 1. And when I do that, I end up with a negative 2x minus c equals an 8. And our original first equation was a negative 3x minus 3y plus z equals 6. When I put them together, I have a new equation. We have a negative 5x minus 3y equals 14. Okay, I'm going to call this the fourth equation. Now we need to put another two equations together. So let's go ahead and put 2, which is 2x plus z equaling a negative 8, and put 3y minus 2z equaling a 6. Okay, to eliminate z, the coefficients have to be the same. The signs are different, that's great. Okay, but let's go ahead, let's go ahead and multiply that first equation by 2. Okay, so let's go ahead and do that. Multiply this by 2. So you end up with a 4x plus 2z equals negative 16. And then we have a 3y minus 2z equals 6. Okay, and then when you add them together, you can't add the 4x and the 3y together, so they just become 4x plus 3y. We've eliminated the z, and then we have a negative 10. So right here is our fifth equation. So notice our fourth equation and our fifth equation only has an x and a y. Now I'm going to rewrite it as a systems of equation. When you do that and you add them together, you notice that the y just eliminates. So we have a negative x equals 4. Divide both sides by a negative 1. So x equals negative 4. Okay, now we're going to use one of the two equations that we created to put this back in and get ourselves the y. Okay, so I'm going to use equation number 4. And that is a negative 5x minus 3y equals 14. And we're going to substitute x equals negative 4. And so that gives me a negative 5 times a negative 4 minus 3y equals 14. And that right there is a 20 minus 3y equals 14. Subtract 20 on both sides. So you end up with a negative 3y equals negative 6. Divide both sides by a negative 3. So y equals 2. There's our other variable. Once I do that, I'm going to use one of the original equations, and let's see, something that has both an x and a y in it with a z. The only one we can use is 1. Okay, so let's go ahead and use 1. Negative 3x minus 3y plus z equals 6. I'm going to put x as negative 4 and y as 2. So it's going to give me a negative 3 times negative 4 minus 3 times 2 plus z equals 6. That's a 12 minus 6 plus z equals 6. That is 6 plus z equals 6. Subtract 6 on both sides, and I get z equals 0. So our final solution is negative 4, 2, and 0. Look how beautiful that is. Okay? And that's it, guys. Good job.